Well, good morning, everybody. I guess we get to wake up this morning and tomorrow morning to my voice, as good or bad of a thing as that may be. Today we're going to be starting out talking about polarimetric radar data. As everybody knows, the 88D network is getting upgraded to dual pol technology as we speak. Should be finishing out this year. And this specifically is going to talk about the TDS, or the Tornadic Damage Signature, today. It was mentioned a couple times yesterday during the radar workshop, is an indication that you actually have a tornado in progress doing damage. One thing we're going to be taking a look at today is how much you can use that information to really talk about, with any skill at least, whether that tornado is a large tornado, significant tornado 2 or up, or if it's a small tornado. The more I'm seeing conversations out there about a TDS, and even mentions that we've seen in radar workshops and other conferences, is starting to get to be an idea. As you see a TDS, you must have a strong tornado because it's lofting debris into the air. And more data that at least I've been looking at and have conversations with people that we may not have the skill to be able to do that. And so today we really want to take a look at a few of those pieces, some case examples, and really kind of go through that. Reischkoff, Schur, Burgess, and Zernick in 2005 really introduced the Tornadic Debris Signature. There's been a couple more papers now going through that, but also just about what the TDS really is. It's really characterized by an anomalously low correlation coefficient and differential reflectivity. So really those two big dual pol moments that we get now with the upgrade. That being co-located with a TVS in the storm. So you've got a good strong couplet in place, and really looking for that correlation coefficient hole, so to speak, in the data. But just wanted to give a real quick dual pol primer just to get everybody up to speed, make sure that we're on the same page so that we can talk about what this is looking at. Horizontal polarity was really the rule, I guess, with the 88D data. That's the way it used to be, the legacy product, so to speak. The dual polarization adds in that vertical element so that you're able to see both of it. The way it's actually being sampled is different, but you get the horizontal and the vertical polarity with that. 2013, we should see the completion of the upgrade to the dual pol. Right now, I think if I remember seeing the map, it's mostly kind of the Gulf states, as well as some of the Department of Defense radars that still need to get that dual pol upgrade done. And we'll hopefully be seeing the completion of that here this year. The legacy products, which is the ones we're all probably familiar with, reflectivity, velocity, which a lot of people probably use just right away, go to the storm relative motion with the velocity, as well as the spectrum width. Kind of the product that no one seems to use as much as I think it is valuable as it is. The new products, of course, are the differential reflectivity. And so these are just kind of the 30-second description of what those are. So really kind of differential reflectivity is kind of the roundness of the scatterers. Is it raindrops falling, like the hamburger buns, or is it round, hail falling? Kind of the quick and dirty definition. The correlation coefficient is really just kind of the likeness of the scatterers. So are things really like in that area as far as the shape that they're in? So we'll take a look at that. Usually CC or rho. In the differential phase, or specific differential phase, just measuring the attenuation of the horizontal versus the vertical phases. We're really going to be keying in on the ZDR and the CC here as we go forward. So how this relates to the TDS, the correlation coefficient, really the minima in likeness due to the tornadic debris being lofted. So you have dust, you have stuff, being lofted by the tornadoes. It's impacting usually populated areas, but we'll also show some cases where you have other non-meteorological scatterers that are causing that minima. It's really being used by the Weather Service a lot, of course, and I've actually even seen in some statements and even LSRs being issued based upon these tornadic debris signatures in it, which is interesting, I guess. I'll leave that there. Quick look at it just to kind of familiarize before we start going through some of these specific cases. This is the 4-panel layout that I'll be using throughout. So the top left is the reflectivity, which I smoothed in this one just to bother some people in the room. It was great. The top right will be the SRM. The bottom left, the ZDR, and the bottom right will be correlation coefficient. So that'll be the panel layout as we go through all the cases here. All right, so really the challenge. So now that we have this ability, can we really use this to gauge how strong the tornado is? There's a draft paper right now out to be published in Weather and Forecasting at some point here, where they would start to use some of the CC and the ZDR numbers to try to come up with both the area as well as the volume of those minima to come up with trying to gauge with some skill the strength of the tornado involved. One weakness of that study as it is right now is they did not capture any zeros or ones with it. So that's something that we're going to be taking a look at here today as well. And really, does this hold up, to scrutiny in the weak tornado cases? So, first example, this one is probably anybody who sits at home and watches radar just because it's interesting when we have these southeast U.S. outbreaks in the spring. Adairsville, Georgia, back on January 30th in EF3. We're going to kind of just step through the radar plot here as we look at it. So, moving into this area now, we've got a very strong couplet here on radar. Moving up to the northeast here, a little bit of a minima on our ZDR as well as our correlation coefficient. Now we're moving up into Adairsville itself, which is really where the tornado touched down. You guys have all seen the YouTube video, so I don't need to describe that. Came into town and actually touched down right through town is where it really got going with that TV crew that happened to be there to see the whole life cycle. Right after it passed through town, you see the big change in the correlation coefficient data. So you've got that textbook hole in the correlation coefficient data as well as the ZDR data as you're passing through. You've got here and, of course, on the right. So really seeing kind of the textbook example of a tornadic debris signature here. And continuing as you move through, now that starts spreading out, of course, as that debris has been lofted. Now it's spreading in the storm as it's going in the updraft and starting to be scattered out as well. And moving out of the frame here, continuing to spread out. Another example, so Chilton County, Alabama, EF2 tornado. Just the one grab of this one. So again, a nice strong couplet, but you've got this in place and you have your ZDR and CC hole here again as well. So does a TDS equal strong tornado? That's the big question, I think. Kind of the conversation around this, it seems to be leaning that direction that, you've got a TDS, you have a tornado. Even yesterday, I guess, at least Kevin a little bit, mentioned to you as well, you've got a TDS. Is now the time to go a tornado emergency? So you have to, well, I don't know, is it? Right now, you have to really think about that. The paper doesn't sample any zeros or ones. So is there really skill to be achieved seeing a TDS and equating this to a tornado's strength? So the next example I want to do is a EF0 tornado. This was from the week after MPX came back with the dual pole upgrade. So it was an interesting example to see. So here you had a good outbounds, some inbounds there, but not really impressive at this point. Moving into the radar sites just about 45 miles to the east here. Couplet gets quite a bit stronger here, and you actually then start to see a small correlation coefficient hole here. And then, although the couplet starts weakening, you now have a pretty decent correlation coefficient hole. So that really started moving through, and see it right here. So this is the EF0 tornado that we have the tornadic debris signature on. Yes, it's decently close to the radar site. We're about 40, 45 miles away from the site, but still a good example. And really what happened here is the tornado didn't do much damage. It was a cornfield, and it actually did take down a barn that probably would have fallen down on its own within the next few years, frankly. But it lofted a bunch of straw. All the straw out of the hayloft of the barn was lofted, and that's what gave us our correlation coefficient. So thinking about that not only from what you think of as a damage signature, shingles and 2x4s and that kind of stuff, really lofting much smaller, non-meteorological targets. So something to definitely keep an eye on. So that's that 0. With this one then, take a cross-section of this minima and correlation coefficient, and you can see vertically kind of how it starts lining up. It's being swept up into the storm and downwind a little bit here as it's going through. Another example, this one, now the latest tornadoes in Minnesota history. In November 10th and 11th last fall, again EF0s. This one's a little bit different just because the storms were booking it through. We're going to be following the reflectivity or the couplet itself, so it'll be kind of a different plan view. But still, as we go through time here, see really the initial touchdown with the storm, some outbounds, not really much inbounds to speak of. As we move forward though, we got some real nice outbounds here, and a little bit of inbounds starting to happen. At least somewhat of a shape, in the reflectivity that would maybe cause a little bit of interest. But there again, we did see that hole in the correlation coefficient as well as in the ZDR. So, 2 EF0 tornadoes where you're seeing that correlation coefficient hole happening. Now, I will give you that it's nowhere near the depth that you're seeing in those higher end tornadoes. And that's really where that paper comes back and talks about. It's that area as well as the volume of that you're seeing those CC minima. But just because you're seeing that hole in the CC doesn't mean it's a big tornado, is really the thing that I'm trying to go after here. You see it go through, and this one washes out pretty quick, so that's the one that you'll see as we step back through, get your CC hole, and it washes out pretty darn quick as that moves off to the northeast. The storm was moving at somewhere around, I think, 45 or 50 knots, somewhere in that ballpark. So, implication of this, one thing that we have to go back to from Jake's talk last evening is the impact-based warnings. So using the TDS, would you really want to, on the sole piece of the TDS, starting to move up into that considerable or catastrophic language that he talked about yesterday? What kind of skill really is there to be had in that moving up to that enhanced language based upon the radar data alone? Of course, in the perfect world, you'd want to have spotter reports to give you some confirmation to have a lot more ability to move up into that enhanced wording if you're even thinking about going there with that. So this another piece is even another statement that's in those impact-based warnings is that spotter statement. So would you really be comfortable moving from a radar indicated to an observed in the warning just based upon seeing a TDS in the data? Is that enough to jump your confidence over and say, yes, there is a tornado there, even though we don't have a spotter, we have a TDS there. Is that enough to say observed with the tornado? I think that's a good question for folks to keep moving forward with. So really in conclusion, there is skill to be shown when assessing the area and volume of the tornadic debris signature, but caution has to be used when equating that to a tornado strength. With the completion of the 88D network this year, we should see a lot more data sets. I think that's going to be the big thing. That kind of nagging question in the back of my mind is the TDS going to be almost like the mesocyclone originally was? The mesocyclone was a rare thing, and all of a sudden, wow, almost all these storms have this. Is the TDS going to follow along those same lines? I think that's at least personally, that's a question that keeps sitting in the back of my head, wondering if that's how this is going to end up working out. And of course, significant future study is really going to be required with this. The skill does not seem to support the replacement of spotter networks. The big thing that you're going to have to think about is, again, that tornado, that radar indicated versus the tornado. We know people react differently, whether it's a radar indicated versus, you know, a spotter, something indicating the tornado is actually there. But how do we get that across in warnings as well as other products to the public based upon this new data set? So that's everything. Are there any questions? I don't know if we have time for questions, Dave?
We do have
All
time
right.
for questions. So